What's going on YouTube? Today I'm going to show you how to create your own version of the Game of Life. Now for those of you who do not know what the Game of Life is, I am going to use the internet's most reliable source of information, Wikipedia, to explain it. So on Wikipedia it says that the Game of Life, or simply known as Life, is a cellular automation devised by the British mathematician John Conway in 1970. So technically it is a automation type of program that you put into the computer and you watch the show. So because of the simplicity of the program, it's really easy to come up with an algorithm for it. And so I went ahead and did it, and I just want to share it with you guys. Right, so yes, it is 3 a.m. in the morning, and I am here recording myself coding on the computer because I am a nerd. So if you still have no idea what the Game of Life is, you can search Google for, or search on YouTube for number file Game of Life. These guy actually went and interviewed the creator of the Game of Life, and he had pretty interesting fact about it, and it turns out that he didn't really like it because it was a mathematician, but whenever people hear his name, they refer to him as the Game of Life creator, or whatever, the Game of Life guy. So the rules for the Game of Life is any life cell with fewer than 2 life neighbors will die because of underpopulation, and no neighbor has a U in it because he's British. Any life cell with 2 or 3 live neighbors live to the next generation. Now, any cell with more than 3 live neighbors dies, as if by overcrowding, and any dead cell with exactly 3 neighbors become alive as if by reproduction. So technically, the any cell has only 2 states, either dead or alive, and the live cell will have a certain condition to continue living, and and a dead cell will have a certain condition to come alive. So I already made it, and here's the result. Let's see. Here's the code, and here's the design. It's pretty straightforward and simple. So over here I have the screen now for some. This is I'm trying to experiment things out, and as you can see, things are already drawn on the screen here, and this is a pattern that I try to experiment with it. So it's supposed to be like this. Let me change a few numbers here. It's supposed to have start with 150 by 100 cell. Alright, and I'm just gonna go in here and let's see, 150 by 100. Wait, 250. I mean, you don't have to worry about this right now, really. This is just the already made program that I already made. Okay, we don't need this. We do not need this either. Okay, let's see. So, is what you're presented with when you start. It's gonna give you a grid of cells, and as you click the mouse and you drag on it, it's gonna create. Well, you can create individual ones as well, but I use a mouse drag so that I can create the cells faster, and if I click play, it starts living and dying by the rules. So there's some interesting fact about it. Now if I create something, this is still too big, I'll go 100 by 50. Okay, so if I create something like this, and this is a really simple thing called the glider. That's what he called, and the glider technically lives like that. If you have something like this, it's just gonna react spontaneous, or react randomly. And if you have something in there, and then it's gonna react differently, and yeah, if you touch it, and it's just gonna blow up. So this is technically what the game of life is, but let's go into the technical part of it. So I am going to use NetBeans to create this program. Why? Because NetBeans, in my opinion, is the best of the best Java IDE for graphical user interface. There might be better ones, but I prefer NetBeans. So to create a new project, we can go to go to File, New Project, or this little icon over here. Doesn't matter. And we click on Java Application. We name it Goal. Technically, it's Game of Life. The naming part is yours. I can just you can just name it anything you want, right? So because I named it Goal, also when you create it, make sure it has a main class in there, so you don't have to like create a main class yourself, right? So now you have a main class. What else do you need? You will need a JFrame, because the JFrame is what you have everything on, and you design it. So because Java is a object-oriented programming language, anything you create will be an extension from a class. So I'll call this the Game of Life.java class. I can call it Game of Life. Ah, jeez, they do not stay in the same package, which will suck. So I try to throw them into the same package so they can communicate with each other better. Sorry about that, but you're supposed to right-click the package itself and create a JFrame in there, not the project folder. You have to create from the package. So anyhow, this is how you create a graphical user interface. I mean the JFrame. So as you can see, if you click into the source code, this thing says Game of Life extends JavaX to swing.jframe, which is what you want, because it has to be an extension of JFrame. And to initiate that, now I'm talking to you as if you do not know what Java and GUI is, right? So well, you still have to have like enough knowledge to go thus far, but here's how you. So yeah, please excuse me if I am being too detailed into these little things here. So I'm just gonna instantiate it. So I'll create a variable called life of the type Game of Life, right? So new Game of Life. Oh Jesus. Okay. So I just created the Game of Life. I'll go get life dot set location relative to. Why do I need this? Because set location relative to null, so that it will bring everything to the middle of the screen. I don't have to set the location myself. Now set no more shading, just the show. So far we have created a JFrame and it shows to the screen. Terrific, right? So now let's design the thing a little bit. Now for the application that I made, the design is quite simple. It's just this, just one little JFrame. So it's one JFrame, one JPanel, 2 buttons, 3 text boxes, and that's it. So what can we do here? Excuse my mouse, because it just randomly double clicks for some reason. So we are creating our Game of Life JFrame. So first thing first, we're gonna drop a JPanel in. The JPanel is right here. Drop it into the frame and then resize it. Resize. Now you only need this size to click with the background or with the JFrame, because we're gonna add some things down here, right? So if we do it like this, yes, it's gonna go with the thing. It's gonna anchor to the JFrame itself, but that's not what we want. And also we're gonna change the background of this thing to a darker color because yeah, about mid-range kind of color here, so that we can actually see it. Because if it blends with the background, we don't see anything. So again, we do not want it to move with the part down here. Now we are going to drop a button in. Okay, make sure that the dotted line that you see the dotted line, kind of click here and click here, so that it's gonna move with, it's gonna be anchored to the J frame, and it's gonna move with it. And then click on the button F2 to change the text on it, and we'll call it play. Right? So we just call it play, and then we can control and paste it, move it over here, make sure it anchors to the bottom. Now make sure it anchors to the bottom. Now this line means, this little blue line means that it's gonna have the same height as that one, and then this thing means that it's anchored to the right hand side of the thing. It gets, Java is quite tricky in terms of designing, right? So now this thing does not expand with the button, so I have to pull it down until, oh crap, my mouse. I'll pull it down until it kind of have those lines. Technically means that it's going to anchor to the button is anchored to the J frame. Now I use the term anchor because I am a Visual Basic programmer, so you can see. And in Visual Basic it has a term called anchor, and it's just anchor the thing with the frame, with the form itself. So now we have two play buttons, which we do not want. We want a reset button. Alright, so that's pretty much it. On my own J-frame here, I have 3 text box. This is totally optional, and for the sake of the tutorial, I will not use those because it just gets a bit complicated, So, what are we going to do in here? Now we are going to need, let's get rid of these because I don't like comments. I do not like documentation. I am a horrible programmer, and I do not like documentations at all. So we are going to leave the main method. We're not going to touch it like ever, right? So there are a few variables we're going to use here. First is a current move variables. Boolean current move more, right? Current move, and it has to be a 2-dimensional variable. Why? Because we need the column and we need the row kind of variable. So current move will instantiate into a new boolean of let's say 200, hold on, 100 vertically and 200 horizontally, and also the left hand side, or the first index, should be the y and the second index should be the x. That's standard, or at least my standard. So that's our standard. So right hand side or left hand side is the rows, and right hand side is a column. Left hand side is y, right hand side is x. Terrific. Okay, now we are going to need one more variable. We call it next move, because then I can just copy these over. There we go, nice and neat. So what do? They just save all of the state of the cell, and the next move will be, because the thing is, when we have a current move, when cells come alive and die, they do not like one cell coming alive does not affect the cell next to it until the next move. So you know what I mean, because it goes by events, right? So it has events, so we have to have 2 copies of the thing, the next move and the current move. and the next move is gonna be, well, let's just go with the flow here. So also we are going to need a welcome back, and sorry for the cutoff. Apparently the free version of Screencast only lets me record for 15 minutes. So where are we here? We are making variables. So now the next variable you're gonna need is the a boolean called play. Why do we need play? Because we are going to put everything into a timer, and the timer will be constantly running, and it checks if play is true or not. So talking about the timer, we are going to have to import the timer in. So import Java, I think the timer is in util.timer, of course. And the timer uses the timer task. So we are going to import Java, the util, Jave, of course, Jave. Oh my god, I am horrible. Sorry, it's 3 in the morning. So, I need to breathe for a little. Java.util.timer task. So, the timer uses the timer task to do things. So I don't think we need to initiate or instantiate the timer here, even though I did that on my version. I mean, on my code, I did instantiate it on like as a global variable, but because it has things to do with changing the interval. Well, it doesn't really, you don't really have to do it. So we need a variable called play. We need those variables. I'm trying to keep it below 30 minutes here because I need it to be efficient. So I think that's pretty much it. We don't need more variables, do we? Well, no, I don't think so. Oh, also, I think the width and the height of the array should be a final number or a final int. So I'll call it width is 200 and hey or height, whatever, because I try not to clash with a keyword. So width will be just, you know, I try to reduce the number of letters so it doesn't clash with the actual keyword. You know, we will come like you know, like we will stumble upon them at some point, and just is better that we don't clash with those. So since that we have those numbers there, let's just go ahead and plug those in. This oh my god, I hate my mouse. There, so that when we want to change the dimension of the array, we can just change one number instead of 10,000 numbers in the code. So I think that's it for the variables. We might create more. Oh, and also those have to be global variables. They have to stay outside of any of the methods, just because it's my algorithm. So if you guys find better algorithms, feel free to slam it in my face and criticize me that my algorithm sucks and you found a better one. So first thing everybody's gonna think of is a repainting method, right? So we are going to use a private. It doesn't really have to be private. Nobody's gonna use your class ever, but it's a good practice to use anything that you use privately for your class. You just declare them as private void repaint. Now if I say repaint like this, it's going to clash with the repaint method of the JFrame, so I will have to redo it into repaint. So there's no paint, but it has to be pain. So repaint. Now I am going to have to use or implement the idea of double buffer. Why? Because if I draw in real time, you're gonna start seeing the screen flashing, and that is not cool. So we are going to have to use double buffer here. Don't worry, I think I'm just gonna throw this code online, or throw this code, upload it somewhere, and you guys can download it and actually look at it. But apparently we have to use double buffer, and to use double buffer, I think you have to use java.awt.image. Yes, image. And import, I think java dot something else. Let me go back. I don't remember what I did, alright? So yes, we have to have that color, that image, that graphics. Okay. Dot graphics. Yes, graphics, because we need to get the graphics out. Java import java dot AWT. What else do I need? I need graphics, image, color. Oh, color. Duh. So why do I need color? Because color is the class that saves all of the colors in the world. And we're going to need that if we want to set the color for the drawers. So we are going to draw everything ourselves. So let's cut everything and go down into, oh yeah, and because we imported those, we need to create the variables of those. So let's see. So still create global variables. First is off-screen image, screen image. Why off-screen image? Because the concept of double buffering is that we draw everything off the screen, and then we draw until we finish drawing everything on that image. We are going to just draw the whole image onto the J-frame instead of drawing directly onto the J-frame. So yeah, that's the technically the concept of double buffer. We buffer it behind the screen and only draw it out until everything is done drawn. So we need the off-screen image, and we are going to create a graphics. Hold on, no, not yet. Oh yeah, we do have to create graphics eventually. So I'm going to create an off-screen graph, technically off-screen graphics, and those have to be global variables. Why? I'll tell you later. Okay, so those are those. Now to create a image, we are going to have to say off-screen image equals create image from what? The J panel. Now one dot get width, J panel one dot get height. Why do we need those? Because oh jeez, no, it's not supposed to be in the quotes or in the parentheses. Okay, so this line is to create a image object for the off-screen image, and then we are going to get the graphics out of it. So off-screen graph equals off-screen image dot get graphics. So technically we are going to get the graphics from the image object. So because it is object oriented kind of programming, so this is kind of confusing. It has a lot of things. So technically what it is that the image object is the image object itself. It is the image, and to draw on the image we have to draw onto the graphics. Right? The graphics is what draws onto the image. Right. So first thing first, we are going to clear the screen, right? We are going to clear the whole screen. And how do we do that? So the poor man's way, or the lazy way, is that you draw a huge square. I don't think there is like a clear kind of a method for graphics. You have to draw a huge filled square, or a filled rectangle onto the image itself. So I would say off-screen graph dot fill rectangle and 0 0. Oh my god. Okay, hold on, I'll use a keyboard. My mouse is just dead, man. So 0 0, and then J panel 1 dot get width, not get base. Jesus, sorry, I just make way too many rookie mistakes here. Get width, and yes, it has to be a J panel 1 dot get height. Alright, so that will fill out the image for you, and all the way at the end we're going to have to draw the whole thing back onto the J panel, right? Because we use a J panel to show everything. So we go J panel 1 dot get graphics. Get graphics out, and then from the graphics we draw. We say draw image. Oh my god! See, this is so stupid. Dot draw image. And draw image where? What image? The off-screen image, of course, and at location 0 0, and the observing. Let's just go J panel 1. Actually, I didn't use J panel 1. I use well, let's just try using J panel 1, see if it works. Oh, also we have to draw it with a color, right? So we have to use off-screen graphics.get color, or set color. Color. What do you want? What kind of color do you want? So I'll go get color. Actually, no, because we already set a color for the background of this thing, right? So we would just say J panel 1 dot get color, get background color. So we'll draw it as the same as the background. And now here's the tricky part. Here's the funny part. We are going to have to draw the grid. Now, as you see, my application is going to draw the grid out, right? The grid will have to be drawn in order for things to work. Like you see the grid. So the grid is not hard to draw, but let's see, it's not hard to draw, no, but it's tricky. So that we're going to have to say, see, let's delete a few things here. I don't like many lines in the middle, so maybe one line to separate the top and the bottom. For int I equals 1, because yeah. So let's use paint to demonstrate things. Okay, say we have a square like this, and we want to draw a line in the middle. So our square has, or our thing has a, let's see, we split it in 3 parts, right? So we have to draw one over here, one over here, no, one over here, and let's just imagine these are all equally spaced, right? So this one is 1 times a third. This distance is 1 times a third. This distance is 2 times a third, and there is no more here. So we will go from 1 to I less than width. We are not going to draw anything at the final, the width, or the width. but I'll call it width. So I plus plus. Hold on, not width. No, I should be height. We're going to use a nested. And yep, I just got cut off again. So what I was trying to say is that we are going to use a nested loop for this. So we're going to use int j equals 1. I'm just gonna type really fast and explain along the way so that I won't mess up again. Right, so j plus plus. So the reason we use a nested loop is that we are going to have to vertically. No, actually no, we're not going to use nested loop at all. We are going to use a loop for the vertical bars and the loop for the horizontal bars. So what we have so far is that now I is the horizontal bars, because I represents y, and on every single y we have one bar from the beginning to the end. Right, so we draw on the off-screen graph dot draw. I think draw line from now 0 for I for y, for x I mean, and I has to be some number, and j panel 1 dot get width. So technically we're going to draw from the beginning to the end, and it has to be some number. So int y equals see, like I said in the paint, I'm gonna, what is going on here? Just maybe yes, never mind that. So like I said in the paint, we are going to divide the screen into the width number of parts, and so we'll have to go I times, or I mean, horizontally we'll have to divide it in, I mean vertically we have to divide it into height times height parts, and times height divided by j panel 1 dot get height. Okay, and then we're going to plug the y's in. No, that's not the right y. This y is wrong. And we'll do the same for the width, but except we're going to fix this to x and fix this to j. I can technically use I twice, but I'll just try to stay consistent with the thing. So I use, so technically it's gonna go draw on now we have to change the x, and x has to stay, and the y is from 0 to the end of the thing. So what I'm gonna do, I'm gonna copy this over and change this to height. And of course there's like a little thing in here where I plug an x in. So what do we have? We have drawn all of these things, and of course we have to set the color of that thing to black. We're gonna draw black bars. Set color, and color, no, not dot black. Yes. Okay. So, and we're going to call repaint. Now, Java is pretty dumb. It doesn't really know when to repaint something, so we have to invoke it. We'll either invoke it at resize or when we click on it. So you have to click on it to invoke it. So I'll go mouse clicked. Yes. Okay, mouse click, and then I'll go repaint. So let's see how far it goes. Right. So and then again, it doesn't draw until we click it and have to invoke it. So apparently something is wrong. I understand that. See, now every single time we resize it, we have to get the graphics out again. So event resize component container component resized. We have to get the thing out, and why not drop a repaint over here too? Right, that should work now. Whoa. Let's see, times height divided by jpanel. Well, you know what, I was really dumb. It's supposed to go the other way around, so it has to times jpanel divided by height. Sorry about that. And again, it's 4 in the morning now. So yeah, so my brain kind of goes cuckoo. And so let's see. I'm gonna use in here. I can. Fine. You win, computer. You win. Divided by width, and this j times that. See how well it works now. So yep, it kind of did, but for some dang reason it doesn't draw that part. So what is wrong? Of course, the part that is wrong is that get height. Hold on. Y. So the Y worked, but Yep, that's how programming feels like. You just keep making small mistake until you get it done. So technically now we have the grid. Awesome. Now we are going to draw the little individual cells, and now we have to use our. Now note how I kind of draw this the grid after I draw the cell, so that the cell doesn't overlap the grid. So I'm going to use a nested loop here. So I'll go I equals 0, and then I less than height, because we use I for height, J for width, or I for Y, and J for X component. So it's a nested loop, so I'm just going to go ahead and copy it over and kind of indent it here, and of course change every single thing in here into J. They kind of got stuck together here. I'm just trying to space them out. So J here, J here, and put some space in here so that it doesn't look too cluttered. That. Okay, looks better. So, what am I gonna do? What I want to do is that I will draw a yellow spot every time it sees a on button. So, to draw a yellow spot, I'm just going to use a fill rectangle, copy it over, indent it. Of course, we'll have to use. Now we'll have to calculate the X and Y for it, which I happen to have it down here. See how neat everything is now? You just copy and reuse your code. That. So technically this is all we need. So we draw a X at J width, right, and J I X and Y, and then yes, we will use the J dot width, but we have to divide it by width. So technically we divide it by how many blocks horizontally and how many blocks vertically, but we don't really do that until. So only draw it when we see if the block is turned on. So if now we draw off the current move array. So current move at I J. If it is turned on, we draw a yellow block. Technically that's what it means, and I'm going to have to get the color in here too. Okay, boom. that color dot yellow. So it's gonna draw a yellow block there if the color happens, or if the block happens to be turned on. So now we're not gonna draw anything. We just drew the grid. Really, we didn't really draw anything else. So to draw technically to turn on every single thing, we're going to have a event and mouse click here. So we'll go back to the mouse click and we're going to add some more code to it. So to turn on the thing, what I want to do is I want to copy the code, of course. So after you have programmed for a while, you'll understand, like, you can just copy your code. Okay, so we will have to turn from the X to I and J. Right? So let's do J first and I later. So we deal with X first and X first and Y later. So what we want to do is that we have to say event dot get X. And event dot get X. So technically what we want is that, let's use paint again. So we have a square over here. We have different little thing and separation here. Nope. Yeah, I'm just gonna ignore it because paint apparently doesn't work well with the program I'm using to record. So yeah, let's just say we have cells like that, and yep. Okay, I'm just gonna ignore the straight factor of it. So this cell is divided into two parts, and if our mouse is on this area, we have the mouse divided by the width times. So if we have mouse divided by let's see, we have the X location here, and we have the X location of the mouse is in the first part is gonna return 0. Second part is gonna return 1. Third part is gonna return 2. So we will have to take the X location and we divide it by the width, and then we times it. Okay. Take the X location divided by the width of the whole thing, the actual the physical width of the J panel, and times the number of times the number of things we have. So times the number of, what do you call it, number of cells, horizontal cells. So that's what we do. We take the X, divide by the width of the J panel times the number of cells. Same goes for I, height. Awesome. Alright, so now we just say current move I J equals, what we're gonna do is that we just toggle it on and off. So we just current move equals not current move. So technically what we have created is that when we click on something, it toggles it on and off, right? Okay, apparently it just keep toggling the first square, which means something is wrong. What is wrong here? So event that get X divided by J panel the width. You know what? We have to multiply it with the width first, because apparently if these are all integers, and if you divide this thing by the J panel first, it's always going to return 0. keep that in mind. Things happen like that. So the order is kind of important because you know. And again, I just got cut off, and well, there goes my promise to keep it below 30 minutes. So what do we have so far? Oh yeah, I think we finished with checking and then toggling the what do you call it, the cells. So let's run and test it out. Yep, then we click on the screen, it toggles the cell. We click on it again, it turns off. Click on it, it turns on. Click on it, it turns off. Terrific. So that's all we have so far, right? That's all we have so far. So we have been able to turn the cells on and off, and we are able to show it out to the screen. What else we need? The play button. Now, the play button is gonna turn the play boolean on and off, right? So technically, the same toggling method. So play equals not play, and so when play equals not play, we're gonna have to play in the state for the program. But I want to change the caption or change the text on the button itself. So I would say if play, then this J button set text, it will be a pause. Else, so technically, if the play is off, I'll set it to play. Yep, and it's gonna toggle play on and off. And let's go ahead and drop a repaint here. It's not gonna hurt. So what we have so far is that we click on it, it's gonna play, pause, play, pause, play, pause. Okay, so I think we're almost done. We are really close to being done. Now all we have is the timer. Let's see. So we're going to make a now before we instantiate the timer. Oh yeah, let's instantiate the timer. So timer time, this equals new timer. This is to create a timer, and then timer task equals new timer task, and then we have to, when we instantiate the timer task, we have to override the run method. So technically void, actually no, public void run. We have to override the run method, then we're done. And then time, well, we're not done, but we are close to being done, right? So time dot schedule, this is to run the yeah, I just hate the tab completion of this thing, man. Time schedule, oh my god, no, this. So it's gonna take, oh, task, amazing. So it's gonna take the task in. This is the delay, so technically at 0 it's not gonna delay at all, it's just gonna run. And our interval, I suggest 100, so it looks decent enough. 100 is awesome. So now what to run is that we are going to have to use the next move we have to decide the next move based on the current move or current state. Current move is technically the current state of the array. I'll try to keep like this whole thing in the 10-minute kind of span, so that I won't get cut off again, because I'm exploding right now. It's 4:20 in the morning. Let's see. So yeah, I'll use a nested for loop here, and I equals 0 and I is less than height. The same cliche that we have. I plus plus, and then another loop for that. So for the J, So now we have to look at the thing. We have to look at the cell and decide if it will die or alive, or die or live, right? So we are going to make. We're gonna make a not void. No, it has to be a boolean. Boolean, of course. Boolean. What do we call it? Decide. Yeah, let's just call it decide. And it's gonna take in two parameters, of course. Int I and oh my god, int j takes in two parameter. Okay, so what does it do? It is going to take the parameter in. It's going to take the location of cell in, and it's gonna base off the current cell. So we're going to make a integer called neighbor without the u because I'm not British, equals 0. Neighbors equals 0, and now we're gonna check for the neighbors around of the cell. So what we're gonna do is that I'll say if I'll go check I. So technically what I mean is that if j is bigger than 0, so if it is not the cell that is at the beginning or on the leftmost, then it's gonna check the neighbor on the left. So if current move on the left, so I is the y and j is so j minus 1. So if it's not like on the side of the screen, on the left hand side of the screen, it's going to check for that, and if there is a neighbor there, or if there is a live cell there, neighbor is plus plus. And now since we're there, let's just check now. We have, if it is not on the left hand side, then we're going to check if it's we're going to check the left hand side neighbor, and we say if I is bigger than 0. So technically if it is not like the topmost thing, if it is not the topmost cell, then it's going to check the up left corner or top left corner, right? So if that, and then we go for the if, another if again, and we increase it. So if it's not the top left, then we're gonna check the top or the neighbor to the cell to the top left corner of it, and then if it's not less than height minus 1, I believe. If it's less than height minus 1, technically if it's not on the bottom left corner, then it's gonna check for I plus 1. Yep, and then we're gonna copy this, and we're going to check if it is on the right hand side of the screen. So minus 1, because number of width, remember, our width is the number of cells horizontally, and the index of the last cell is the number of cell minus 1. It has to be less than the number of cell minus 1, right? So what have we checked so far? We have make it into plus j plus 1, technically check the neighbor on the right, and the same cliche we have, but this time we're gonna have to check the right hand side. So far, let's see, we have a, oh my god, so far this is what we have. You know what, you just try like this. So these are cells in the middle, or our cell is in the middle, and one cell only has 8 neighbors, right? So we just do, if statement to check, conditionally check every single one of them. So far we have checked this neighbor, we have checked this one, check this one, check this one, check this one, and check this one. What else were we missing? This one and this one. So I am just going to copy and paste these out, really, so that if I is bigger than 0, then check the top neighbor. Yes, the top neighbor. And if I is less than height, technically it's right here, it's this line right here. Then check the bottom neighbor. So that now we have checked everything. So now, see, yep, 8 neighbors are checked. So now we will conclude if, so the only reasons for it to live, or the only conditions for that cell to live is that if neighbor, the easiest one is neighbors equals 3. If it has 3 neighbors, it's gonna live no matter what, right? Because it will, if it's already alive and it has 2 to 3 neighbors, it's gonna continue living. If it's not alive and it has 3 neighbors, it's gonna be born. So return true. If, now we have to use a if statement, what do we call it? A end statement here. So we have to use current move at this location. So technically, if the current move at that location, if it is alive and neighbors equals 2, then return true, or else return false. Because so the rest of the cases return false. Then in here we have, oh, also when it runs, it has to check if play. So only when play is true will it run this block, or else it's just gonna, you know, it's just gonna pause thing. So we'll say next move at this I and J location. Now next move we'll use the current move. So decide at this location. So at this location it decides if it's gonna live or die. Alright, and now we have to make a copy of that. Why do we have to make a copy of that? Because we can't just say current move equals next move, because then it's gonna, you know, refer all of the current move into the next move array. Because remember, an array is a reference type. It is not, it's a pointer. It's not a actual array, right? So a integer is a primitive data type, and it has its own memory location. But an array of integers, or an array of booleans, are actually pointers. And if we say current move equals next move, then when you change the next, or you change the current move, it's gonna change the next move also, which is not fun. No, it's not fun. So current, so we're gonna copy every single thing of the current move to the next move, or next move over to current move, of course. It's not I and J there, it has to be this. And then we're repainting. I think that's it. We're done. Hopefully. So, here we have a thing, and let me try making a glider just to make sure it works. Moment of truth. Yes, it works. Awesome. Amazing. And we can tamper with it also. So yep, I think that's it. It's been an hour, or actually 2 hours. Well, actually an hour, yeah. So that's a glider, and there are other types of patterns here. Now, because I am using a potato computer, apparently it doesn't work down here for some reason. Huh. Does it? No, it doesn't throw any array index out of bound. Only works in this region of the screen for some reason. It must be something wrong. Oh, we forgot the reset button also. So yep guys, I found out why it only worked on a certain region of the screen is because of this guy. I is less than height. Yup, it's those little mistakes that drive you crazy sometimes. And now it should work flawlessly. Now, array index out of bound. Oh, shoot. No, I is height, of course, but, I is height, but J has to be width. Yup, now it should work flawlessly. So if I click on this region of the screen, it will draw points and, it will show, and then you click play with it and you see sometimes it just stops. That is not because the program stopped working, it's just coming to a stable state. And yep, that's how you create a glider. And if you don't really know, there are certain patterns on it that you can take a look at, like if you have a bar of 3 dots, it's just gonna spin around like that, and you can mess around with this thing, and it creates live and it dies, and it just like make really funny patterns. And yeah, so I actually had a lot of fun with it. Oh, also you have to finish the reset button also, which will not be that big of a deal. See, it spawned glider by itself. See, these are gliders that it spawned by itself. So yeah, the algorithm for this thing is quite simple, but what it can do is so much more fun, because like it's more interesting, and there are actually many people who actually like make a lot of fun like awesome patterns online. It's just based on all these simple things. So let's go ahead and finish the reset button. The action performed. Alright, so action performed on the reset button. What I want to do is I'm just gonna reinstantiate the boolean, and let the garbage collector collect all of those, so that I don't have to like go through the whole thing and do a nested loop and then set everything to 0. That is for the weak. I'm too lazy for that now. So I think that's it. That's the whole thing. And if you're like me and you want to mess around with it, you can technically see. So yep, press the reset button. Everything will be set to nothing. And yeah, see here. Let's make a huge mess on the screen and see if the reset button works. Yep, and then create boom. So if you're like me, you would want to drag the whole thing on the screen. You just don't, like, if you see on my version, I can drag and draw like a whole bunch of things on the screen. It's not hard. If you want, you can bear with me for a little bit, and I'm just gonna show you here. So how do I do that? I just, instead of a mouse click, what did I do in that? Oh, I actually have to import the Java swing that utility here. So I'm just gonna copy everything over. This is the extra part, really. It's not the main focus of the tutorial today. So if you want to mess around with it, you can import swing utility. Now the swing utility will, the main reason for that is that we want to drag on the screen, but we want to check what button it press, right? Because you want to draw out with the left mouse button, but you want to delete with the right mouse button. So instead of mouse click, we are going to put it into a mouse drag. Mouse motion, mouse drag. So mouse drag is technically the method that only invoked when the mouse is clicked and dragged on the screen. So swing utility dot is left mouse button event. Awesome. So if it is, then do this. So now it's not toggling on and off, it's just good old turn it on or off. So no, not one, true. Because okay, else turn it to false. So now you can totally drag a whole bunch of things onto the screen and then click play, and it's just gonna pop everything out, and then you can just like while it's playing you just drag on the screen and create like a whole bunch of mess around. See, now it's starting to get like really crazy. And of course, test the left mouse. So, yep, I mean the right mouse, it will delete. Right mouse will create. Left mouse will delete. Exactly what we need. Boom. So yep. And again, I'm going to post this application. I mean the source code on online. I'm going to post this whole project. I mean, yeah, the whole project I'm gonna post on MediaFire. So I guess that's it for today. Thank you for watching, and I'll catch you later.